Hello everyone. My name is Adiel Caleb. I came from Indonesia, and today I'm from fundamental mathematics class. I'm going to teach and explain about the function and their transformation. So first of all, we're gonna learn about a lot of functions here. So we have graph x. So the graph will be like this. So I'm using two different colors in order to difference the line. And second is the graph of x squared, and it should be like this. Okay, the third is the graph of x cubic. It should be like this. Okay, and the fourth, put this way. Actually, it's the same like x squared, but it seems needs very larger areas like this. Sorry. Okay. Next is the graph of x powered by 5. Okay. So it will be like this. And we have graph of x powered by 6. So it must be like this. It's actually like square. Sorry. And we have graph of 1 divided by x should be like this. And the last we have the graph of the square root of x. Should be like this. So these are the example of the graph that we might use for to do the sum of problems that we might have. So first of all, I'm going to talk about vertical shifted of graphs. So first, vertical shifted. Vertical shifted. So it is about either up or downward of the graphs. So for example, we're using fx equals x squared. So the first thing we need to do is first we take a look to the equations, the fx equal x squared. So this is x squared. So we can use the graph there, the graph of x squared. So it must be like this. So, oh, I'm sorry. For example, like this. So the points should be x squared, and then this is the domain, and this one is the range. So actually it depends on the C. So actually vertical shifted is determined by the constanta, for example the C. So if the Z over than 0, so the graph will be open upward. And how is the Z become less than 0? So it must be open downward. So for this example, zone is equal C. So this is the first graph that we have. So the graph itself so we have graph of x squared. So it must be x squared, and this is x comma x squared. So if there is, this is for C over 0. So we got the conclusion, if the C over 0, it will be open upward, and it should be go up like this. So it will be x comma x squared plus C. Sorry, it's not open upward, but it's going up, and this one is going down. So if the C over 0, it will be going upward. And then the second one is if in this case the C below than 0, so it must be going down. So for example, we're still using the same equation for if x equals x squared. So for example, we have this graph of x squared, which we did before, and this one is x point x squared, and then it will be going down. So this one becomes x squared plus c. It depends on z, so the c will be the minus. So in vertically shifted, we can give conclusion that in order to find the new equations, we can use this. With the c over 0 will be up, c with less than 0 will be down. So the domain of the equation should be the same, and the range will be changed based on the situation. Okay, so now we're gonna talking about vertical stretch. Let me press this. So vertical stretch are compressed by a factor of c. So for example, we use y equal x, then the c will affect the equation. For example, fx times by c, and the conditions will be like if c over than 1, it will be stretched. If 0, if c is over than 0 and less than 1, it should be compression. So, for example, we have gx equals 3 times by root of x. So first, the thing that we should know to know is the c. So the c we got here is 3. So it can be determined x squared is vertically stretched by a factor of of 3. So why it's become vertically stretched? Because this is the c. The c is 3. It is over a 1, so it must be stretched vertically. So the second thing we need to do is to draw the graph. But we should know what graph we must to draw. So we got the square root of x. So as I have elaborated above from the beginning, I have mentioned the one of the graph. So this one is the graph of x squared. So we must use this. So this is the y, it is to be the x. For example, this 1 is 1. It's the root of x. So we got this graph, and then we change the graph to is vertically stretched by a factor of 3. So it must be like this. Phi okay, so as we can see, the graph from 1 will change to 3 because you just need to do the times, like 3 times the root of x. So this will be the result of the graph that has stretched vertically by a factor of 3. Okay, now I'm gonna talk about next. I'm going to show you about reflections across the x-axis. For example, reflection from the x-axis. For example, we use fx equals square root of x. So it must be x point x, the root of x. So across the axis, x-axis. So the thing you should to do is you just flip the graph from the x. It's like a mirror. So for example, like this. First, you must draw the graph by determining function. Like if this square root of x, so we can use this graph. So it will be like this, right? It's the graph of square root of x, it's y, this is x. So for example, this is x1. So the reflections of this graph should be like this. It will be the same as I told, it's like a mirror. So this one should be x point minus square root of x. Okay, so it's all about the functions and of its graph transformations. So I hope I explained it properly and